Okay, so based off those formulas I just had you guys write down, this should be very simple to solve because I kept it as simple as possible with the starting parametrics. X is 3t, y is 4t. So when I solved it, I got, let's see, dx dt equals 3, dy dt equals 4. The speed is 3 squared plus 4 squared square root, which is 5. The slope of the path, now here it says 4/3. The math behind this again would have been your dy dt over your dx dt. That's where I got the 4 and the 3, which is just 4/3. Okay. Now I want to show you it's also 4/3 by going to rectangular first and then taking the derivative. So if I convert to rectangular, I go t equals x over 3. You throw the x over 3 into the t for the y, and you get y equals 4/3 x. And when you take that derivative, you get 4/3. Okay. Now I had this animated. I just didn't pull up the file. This is the animation that I had built for it. Kind of look at the program. If I changed A, if A went live and A became a slider, the orange would move to the right, the purple would move up, and the blue would move on that road. And that road is I-76. It's y equals 4/3 x. Okay. Every second, the orange would have gone 3 to the right. Every second, the purple would have gone 4 up. So every second, you would have had this triangle being built. Every second, you would have had this triangle being built. A 4 and a 3, which gives me a 5 for the blue. So on the road, I'm going 5 feet per second on that blue road the whole time. Okay, so that's a straightforward one. So now I want us to look at this one here, where exact same 5 questions, same formulas, but I have sine of t and cosine of t. So I want you to try out this circular path, and then I'll walk through some of the stuff with you on this. So try out these 5. I'm going to hit pause. Okay, so on this, I want to make sure you understand that. Question 1, question 2, question 3, everything's going to be in terms of time. Okay, it's either time or numbers. So on all 3 of these, it is okay to be in terms of t's. So when I find the slope of the path on number 3, it's in terms of t, because it depends on at what time are you talking about. So as I'm driving on the road, at time 2, what's the slope of the path? At time 3, what's the slope of the path? But then when you get down to here, and you look at these problems down here, these are going to be in terms of x's because I'm converting to x's. And in fact, it might be in terms of x's and y's. 4 and 5 are about the physical spot on the map. 1, 2, 3 are about the time that you are at a certain place on the map. Linnea. Right. How do we check? Good. So Linnea's question is, how do I check 3 and 5 then when 3 is in terms of t and 5's not in terms of t, it's in terms of x's? That's what I'm going to show you on the next page. Okay, so derivatives on 1, cosine of t and negative sine of t. Then the speed is cosine squared plus sine squared square root 1. Again, I told you 1, 2, and 3 is going to be in terms of time. And it's kind of cool that number 2 has no time in it. It's constant. And I'll tell you why it's constant. You know that this is a circle. You know the radius equals 1. So let me change the color so it pops out more. So you know it is a circle with radius 1. What's the period? 2 pi over b, which equals 2 pi over 1, which equals 2 pi. The 1 because there's a 1 in front of the t on each of those guys. So it takes 2 pi seconds to, let's see, I start here. It takes 2 pi seconds as I go right to get back to there. Next question is a geometry question. What's the circumference? 2 pi r, which is 2 pi times 1, which equals 2 pi. So if the circumference is 2 pi and the time it takes to rotate through that is 2 pi, go back to middle school math. I got distance equals RT. I travel 2 pi. It takes me 2 pi seconds to do it. What's my rate? Well, my rate is 1. So I'm a constant 1 on that road the whole time. Okay? Sometimes I can get it where it's not just a constant. Okay, now when I do the slope of the path, I do the dy over dx, and I get negative sine t over cosine of t, which is negative tangent of t if you want to simplify. Again, Linnea's question is this, but Bach, on 5, it's going to be in terms of x's and y's. There's no way this equals, because this is in terms of t's. So I convert down to rectangular. Which one's the correct conversion, or the better conversion? Please do that, and do not do that, because that makes no sense to you. Now, how do you take the derivative? There's 2 ways. You can do implicit, which is not what you guys think, but it's a lot easier, or you can do explicit. Explicit, you would need to go get y equals first. So you have 2 choices when you take the derivative. You can go get y equals first, which is annoying because then you have that square root guy. Then you have to do the kind of stamp address with square roots. Or you can do it implicitly. And the whole thing with implicitly is, remember, anytime you take the derivative of y, you get a y prime out of that. Now I'm starting to highlight lots of things here. dy dx is negative x over y. dy dx is negative x over that chunk, but that chunk is y. And then up here I highlighted the same colors on negative sine t over cosine t, because who is sine t? Way up top, who's sine t? X. That's negative x. Who's the cosine of t? Y. Now a lot of people are picking up, Rowan. I know you wouldn't pick up right now because you're on a flight somewhere and looking at a laptop and you're just relaxing. Everyone else was like, I want to go to Raising Cane's. But I have 1 minute left, so I'm going to show one more thing. The last thing is this. I'll let you guys take the notes later, but think of it this way. I'm going to also ask at some point, find where you're flat, horizontal, or where you're vertical on the road map. So think of like when you're driving a car. A lot of us have in our rear view mirror now the driving northeast, driving north, driving west, that type of thing. So while you're driving on some crazy windy road going up to Horsetooth, I'm wondering, do I ever go east and west? Does my rear view mirror ever say east or west? That would mean my road is horizontal on the map. And if I'm ever going vertical on the map, that means my rear view mirror says I'm driving north or I'm driving south. So to get that, you're going to find your derivative and set it equal to 0. That finds you if you're flat. So if I have this derivative and I want to know when am I flat, well, the key to finding flat is setting the derivative equal to 0. What color matters if I'm setting the derivative equal to 0? The blue. So if I set the blue equal to 0, I'll find where it's flat. When do I get an undefined slope or a vertical slope? When the bottom is 0. And the bottom is 0 when I set green equal to 0. And in this, I have 2 places where I'm flat and 1 place where I'm vertical. If I show you on Desmos, I have 2 places where I'm flat, meaning I was driving east-west, and 1 place where I was vertical, where I was driving north-south. Okay? Homework is on the last page of the notes. We still don't know when the test is, but it's in a week and a half or so. Have a great weekend, guys. Bye.